Today we're going to look at actually finding angles and the ratios that go with them. So yesterday we set up ratios. Today we want to actually find out for certain angles what those ratios are worth. Today we're going to be looking at angles that deal with 30s, 45s, 60s, or multiples of those, 120, 225, 300, and so on. Okay, and we're going to do this without a calculator. So put calculators away. We won't need those today. We're just going to use some ideas as opposed to using our calculators, because our calculators sometimes lie to us and they don't tell us exactly what's going on here. Okay, before we get started, we have to talk about some triangles. We have to build these triangles, if you will. We call them special triangles. The first one's built from a unit square. Yeah, the easiest square we can think of would be a square that has sides of 1 and 1. And if we were to divide that square in half either way, and through the diagonal, we get a right angle triangle, okay, which would have angles of 45 and 45 in them. Okay, so if we transfer that over here to this little triangle, I got 45 and I got 45. The two sides would be 1, and if you think of those as your x and your y direction, all I'm really missing is my r direction. So to figure out r, we can use our Pythagoras idea, 1 squared plus 1 squared equals r squared, or 2 is r squared, or in this case, r is root 2. Okay, so we call this our first special triangle. We call it a 45, 90, 45 triangle, and it's got sides that are both 1s and two angles that are 45s. The second special triangle we're going to develop comes from an equilateral triangle. Now this time, instead of picking sides of 1s, I'm going to pick sides of 2s, because what I want to do is divide this triangle in half nicely. And I can divide 2 in half really nicely, and it becomes a 1. So if we take this triangle, move it over to the side over here, we now know we have a side of 1. We've got a side of 2 from the triangle. There's a 30 up on the top because we took the 60 over here and divided into 2 equal halves, right? So 30 and 30. And this time we've got ourselves an x and an r, but we're missing a y direction, a vertical direction. So if we go back to Pythagoras, 1 squared plus y squared equals 2 squared. Or in other words, y squared is 2 squared minus 1 squared. So y squared is 3, and y is the square root of 3. Okay, so we move this over just a little bit here. We now have a second special triangle, and we call this one the 30, 60, 90 triangle because the angle's inside, and it's got a 1, a 2, and a root 3 in it. We're going to use these triangles over and over and over again, so it's kind of helpful to know a couple tricks about them. Okay, you might notice between the two triangles there's only ever one root sign. Okay, you never have two root signs. You always have a 2 on the hypotenuse on the r. One time it's a root 2, one time it's a regular 2. And one of the most important ones is a 3 and a 30 always go beside each other, in particular a root 3. Okay, so we'll come back to those when we start using them, but those are some tricks that you might want to remember. Okay, to do exact values without using a calculator, there's a couple of steps we're going to follow. Number 1, we have to draw the terminal arm at the correct angle. So we got to figure out where is 30, where is 60, where is 240, things like that. We always want to make a triangle with the x-axis. Remember, x is your horizontal axis. We're going to use our special triangles to label the angles inside the triangle. And then we're going to fill in the ratio values using Sir Sixertix, that magic word again, to get the exact value of any angle that we want. Okay, so let's look at the first example here. Okay, notice that they're all 30s, so we're actually going to draw one triangle. Down the road, we'll have to draw multiple triangles for multiple problems, but here, because we're all 30s, we only need one. All right, here's 0. That's where we're initiating. We're going to rotate counterclockwise until we get to 30 degrees, which is about there. There's 30 degrees. Yeah, step number 1, drawing the terminal arm in the correct position where we terminated. Step 2, we want to make a triangle with the x-axis. Here's the x-axis right there. It's a right triangle. Step 3 is we're going to fill in the sides and angles according to our special triangle. Well, if I've got a 30 and a 90, the other one has to be a 60, which is one of our two special triangles. And if you look back for a second, we always said that the 30 should be beside the root 3. And we also said the hypotenuse always has a 2 on it, and we know it's a regular 2 this time because we already took care of a root sign. And this triangle has a 3, a 2, and a 1. And there's our three sides. Okay, so there's our diagram that we're going to be using to actually solve these problems. Let's move down a little bit so we can look at the question now. Okay, I want to find the sine of 30. The sine ratio, Sir Sixertix, is worth y over r. Well, in this diagram, the y value is 1, the r value is 2, so the sine of 30 must be 1/2. If you were to pick up your calculator and punch in sine 30, sure enough, it comes out to 0.5. And if we try cos 30, cos is x over r. In our case, x is root 3, and divide that by 2 for our r value, and there's the exact value of cos 30. Our calculators can't do that. Most of the time, we punch in our calculator, it comes up to 0.866, and a big long decimal never ends. This is the exact value. And if we do the last one, tan of 30, tan is tix, y over x. Sorry, that's a y up there. And in our case, 1 over root 3. Okay, and then we found the exact values of any angle. Now we can take these ideas and do other angles. There's a few more steps there, so we'll look at the second video about angles that are bigger than 90 and go with those ones.